So, welcome. Is everyone here? Like, do you know if anyone is still coming? Or should be fine, right? Let's get started. Welcome to the shaders and real-time VFX presentation. For whom of you is this the first workshop in this series that you're following for the game dev intro? Nobody? You've all done the previous one, the 3D modeling one? Cool. Right, because there's going to be some topics from that will come up here. My name is Thijs. I work here as a game developer, game designer, and I dabble in special effects on the side because they're pretty, and I like making good-looking games. And that's also the goal for this session. It's going to be sort of an intro to shaders. How can you get started with them if you haven't used them yet? And if you have used them and have gotten a bit comfortable with them, give you a bit of a toolkit, let's say, to think in terms of what you can do with them. So, first I'm going to cover what are shaders and why should you even care about them, right? Because you can make a game without ever touching them, so why are they important? What can you do with them? And then what I just described, some of the toolbox. And hopefully that will be a good starting point for you to, figure out cool tricks that make your game run faster, or gives you a certain effect in a more efficient way, or it just makes the game look better, which is, it's a core part of the experience in many cases. So can be quick gains there. This talk is not about all of the technical stuff. Like, you can go very deep into shaders and rendering and the graphics pipeline, and we'll be here for the next 4 days. I don't know half of that stuff, so we're going to keep it high level, what the concepts are, and the basic tools that you'll be able to use in most situations, and not so much ray tracing or all of the fancy newfangled tech. So I already checked earlier. Everyone's got the shader editor and the high definition render pipeline, if I'm correct. We do all still need to do one little bit of setup before we can actually start using it, but we'll go through that in the first sort of hands-on part of this talk. That's also a note. This is going to be less of a presentation and then you just do your thing. We're going to show you a bunch of stuff, and then you can work along, try how it works, try different things, and really see how it works. The presentation will probably continue after the dinner break as well, but we're still going to have time to work on your own stuff. So we don't need this. That's nice. So to kick things off, a very brief overview of the technical stuff that you don't really need to know, but you kind of still do need to know to make sense of the rest. Like, most of the time when you're working with shaders and something doesn't work, it's because of one of the concepts here. So I'm just going to go through it fast. If there's something unclear, I can explain later. I'm just going to try to keep this short, okay? So what are shaders? They're, yeah?
Slightly standing in front of the screen for me.
I can move a little bit. That's an issue. Can we move the rig a little bit?
Sure.
Oh, exciting. This is going to be a good shot. If I stand over here, will that work? Oh, this is a heavy table. Jesus.
Because you're heavy left.
Yeah, probably. It's better?
Yeah.
Okay, cool. So, shaders. Essentially, you can say that where most of your program runs on the CPU, right? Your processor, your logic, your data, operations and everything. Shaders are programs that run on your GPU, so your graphics card. And whether you know it or not, every single pixel on the screen has gone through one or more shaders before it gets there. It's the only way to get something on the screen in modern game engines. So the thing is, where programs on the CPU can be very complex, lots of branching and abstractions and reflection, and all of the nice things we have nowadays. Shaders are much more primitive. They tend to be linear. They're made to be run parallel. So instead of one program that you run that does all kinds of things, there are millions of instances of a simple program that all run at the same time, one for each pixel on your screen in some cases. And they're mostly linear because you want to be able to do all that fast, right? So too much complexity makes that impossible to do. So that's really what your GPU is good at. Lots of parallel stuff that doesn't talk to each other. And what they do is they take all of the data in your game, so your models, your textures, where they are in the world, where the lighting is coming from, what color it is, how far away everything is, and it turns all of that into one single color. That's the only thing. There are other applications that, like I mentioned earlier, like CUDA, where you can use that to calculate things for the logic part of your game, but we're not going to be covering that here today. So it's just color is the output. So to put that visually, if you have this model, you can put different shaders on it, and all of these are the same model. So very intuitively speaking, it determines how your model actually looks when rendered. So here's some terms you may have known if you've done some 3D modeling or worked with some lighting or rendering in the past. This is all the same model, same lighting setup, but different shaders and different lighting models. Doesn't matter, you don't really need to remember what these are, but you can see they influence the quality of what you're rendering quite a bit. Like some things look metallic, others look like clay, others look like a cartoon. So that's one thing you can do with it. So what is a shader? You've got tags and attributes, you've got properties that you declare, like, hey, I need certain things, and you've got the shader functions, the actual logic that runs. So tags and attributes, you can think of things like I'm transparent, I'm high detail, I'm low detail, I am one-sided, two-sided, that sort of stuff. Your properties are basically declaring if I'm going to render, I need a color and a certain texture, and I need a certain value to be set before I can render. And then you've got the functions. Now, then you've got materials. A material has a shader assigned, so if you've made materials in Unity, you've probably done it in the last workshop, right? Making a color for a certain model. Standard shader has all of that stuff already abstracted away. There's a lot of options you can do, but that's just one of the available options. You can make your own shaders. In the material, you set data for the properties that the shader needs. So it says, okay, here's your two textures that you need to render, and then the functions will run once you start rendering, and they will spit out one color for each pixel. Yeah, there's a bunch of built-ins. Unity gives you a lot of stuff for free. That's a good thing. Use it. So what does it give us? You've got all kinds of position, all of your model data, where it is, how big it is, how it's rotated, where each individual point is. You've got where the camera is, what its viewing angle is, how far close by it will render. You've got lighting, you've got a bunch of stuff. This is sort of an overview of the stuff we'll be using, and this is the stuff that we'll be using a lot during this workshop. But this is more for your reference after we've done this whole session, and you can look at it. So, what happens when you try to render with a shader? Roughly speaking, and this is not entirely technically correct, but it is simpler to understand, you've got 4 steps. You've got your pre-process. That's basically where the engine, that all happens behind the scenes. The engine takes your model, your whole scene, everything, and prepares the data to send it to the GPU, like all the data that it needs to render. So say we've got the simplest model possible, triangle. 3 vertices, edges between them, and each vertex has a certain color set to it, red, green, and blue. Keep it simple. You've got a camera, and it's looking pretty much directly at it. What pre-process step basically just gathers that data. Then you've got your vertex shader. What that does is it runs once for each vertex in your model, and it does a sort of projection, right? Because this is 3D stuff, but the end result you want is a 2D picture, so you need it somehow projected onto a flat plane. This could be the output of your vertex shader. It flattens everything, does a certain perspective projection, and your points end up on a flat plane. Then rasterizer runs, which creates fragments. For now, you can just think of those as pixels. Each fragment is a pixel. And it interpolates all of the data between these. So, right, if we tried to render this right now, there would only be 3 points on the screen. Whereas there's actually supposed to be a surface in the middle. So what is the color here? It's supposed to be purple. It's in between blue and red. So that's what the rasterizer does. It turns that into this, so that for each pixel that you sort of, right, if these are your pixels and you want to sample that, you can get a color back. Then your fragment shader runs, which is a pixel shader, and that runs once for each pixel, and that's what I talked about earlier, where it spits out one single color. All of those colors are assembled in the order that they're supposed to be on the screen, and that's your final image. And that samples this data once for each pixel, sets what the color is, and then spits it out. What we're going to be dealing with tonight is mostly these 2 steps. Like, this is behind the scenes, this is behind the scenes, and actually most of this is also, you can safely ignore it and nothing will really go wrong. So is all this necessary? This is the vert frag shaders. That's a common approach. It's very direct, right? You're writing code that will compile to something that runs very fast on a GPU. That allows you to optimize it. It allows you to, do it as cheap as you can, as fast as you can, and you have full control, but you have to do everything yourself. And these can get quite sizable once you get into more complex effects. Unity also offers surface shaders. So surface shaders are sort of an abstraction where instead of defining all of the operations that these steps have to do, you define material quality. So how metallic is it? How transparent is something? How shiny is it? How smooth? That sort of thing. And then from there, Unity can generate the vertex and fragment shaders to actually render that. Well, they're written in code, terrible code. It's NVIDIA CG. It's a fairly old language that isn't actually in use anymore, but Unity still uses it for some reason. I don't know why. So let's not do that. Why we had to install the package, I asked you to. Shader Graph is a visual editor for the same thing. So instead of writing all kinds of non-syntax checked code, you can just drag a bunch of nodes together, immediately see the end result, and there you go. This is a free built-in. I think it's still in preview for the current Unity versions, but it should, it's still under development, so it should become better over time. Other alternatives are Amplify Shader Editor or Shader Forge. They're paid packages, and they tend to have a bit more convenience features, where Shader Graph is rather direct. It's like, right, this is how you have to write it, and I'm not going to tell you why. These simplify things a bit more, so these are more, the concepts in these are also more applicable to other engines like Unreal Engine. This is almost exactly the same as the Unreal Material Editor. Unfortunately, it's paid, so we're not going to be using that tonight. I do recommend it, though, if you dive further into this. So, from this whole talk, remember only this. Everything passed through a shader to get onto your screen. So even if you've never used them consciously, you have used them. The GPU interpolates everything so that there is data for all the space in between the points of your model, and you don't have to work like it's 1970 anymore. We're going to use modern tools to make shaders. Yeah, so now let's get to the fun stuff. I'd say we should get all your projects set up. Do you all have the Unity open with the repository, or the project, rather? I'm going to switch as well. For some reason it's compiling. Yeah, it's okay. So the one downside to the version of Unity that we're using right now in Shader Graph is that you have to use one of the scriptable render pipelines instead of the standard system in Unity. And the only one available in this version is the high definition render pipeline, which is fancy and way above, like it's not even done yet. So it's got to be a bit glitchy, most of the examples we have tonight. In later versions, you can actually just use universal pipeline or low weight or whatever, lightweight pipeline. Should all be fine. So one thing that we all have to do before it will actually run, like if you try to create a shader now, it would create a wonderful magenta color, which is shader language for it's broken. You're going to see that a lot. The shaders, they're not easy to debug. They just give you a purple color and say like, doesn't work. What we have to do is go into the project assets and then go to create. And then I have to quickly check where it is. There should be a scriptable, oh geez, it's hidden so well. Rendering. Yeah, there. Under rendering, there's high definition render pipeline asset. You have to create one of those, name it whatever, it doesn't matter. We're not going to change any of the settings, just use the default.
I have a question.
Yeah.
When you open the latest project,
Mm-hmm.
you receive some kind of errors.
Oh, no doubt about it. I can quickly check, 1 second. Oh, that's a serious one.
So the previous project
Pro build.
opened, yeah.
Oh, interesting. Oh, can you continue? Yeah, this may be that you have to re-import the package. Like you see, you downloaded the asset on another project then, or?
Yeah.
Ah, okay, yeah. I don't think it transfers over. I do have some instructions in the PowerPoint later on to fix this. It should be fine. I'll help you get set up later. So has everyone found that option to create the asset? Okay. Then you go to Edit, up in the menu bar. You go to your project settings. Then you have Graphics tab on the left, and then at the top here it will show you the settings for the render pipeline that you want to use. You drag the asset you just created into there, and that will tell Unity, hey, I want to use these default settings to render, and from there on everything should work. So in this case I can just drag this over there. It's going to probably take a while. Not sure why. Looks good. And then everything works by the look of it. I have is everyone up to date with that?
No.
No? No, you're still loading. Yeah, I'll well, Nix. Okay. Yeah. I'll just
Because you have a lot of errors.
oh boy. Yeah?
Een beetje de weg kwijt.
Okay.
Hij zit nu precies, want het is nu. Ja.
Ah, yeah, here. Okay. Here, create rendering render pipeline asset. No. Yes.
Where is run?
Projects. Yeah, it's hidden very well, but it doesn't have the package yet in this one, so it won't show for you. I think I have to fix something. Dit hier even inzetten. Dat zou
Weet je zeker dat je de nieuwste versie hebt?
Dit is gewoon even een instellingsdingetje voor de graphics.
Zou ik even checken?
Als je het niet doet, dan zie je niks. Dat is heel irritant.
Ik heb nu al meerdere keren gehad dat ik echt...
Okay, so if you go to the assets folder, you've got the workshop 4 folder, and then scenes, and then let's say open one UV, and then scrolling. And then there's a scene in there, UV offset, which is the scene I have open right now. Has everyone found it?
Scrollen?
Yeah, scrolling, yeah. So there's probably going to be a lot of purple stuff for you then, or... Yeah?
My magenta stuff is not just black.
That's better, right?
I have a lot of files and
Yeah, seems good. Yeah. This is unfortunately the downside to using a preview package. All right, so for everyone that has managed to get to this point, I'll help the rest of you along for a bit, just to keep things short. Let's create our first shader, just so you know how to do it. And we can just create something basic. Like you already see two planes here with very simple custom shader on it. Let's create something new. So, I don't know, create a sphere or something. Seems nice. Then if you want to create a shader, you right-click in your project assets, create, shader, and then in this case we have to go under HDRP, which is the high definition render pipeline, to get shaders that are compatible with the system we're using now. And then there are a bunch of different types. The two main ones to pay attention to are lit graph and unlit graph. Lit graph is a standard material like you already know it. Unlit is one that doesn't receive lighting information, so it's cheaper. It's also better for different effects, like if you're doing a fireball, it doesn't really have shadows on a fireball, so you don't need a lit graph for that. So let's create a lit graph. In this case, call it whatever, doesn't really matter. That will create this little file, and then if you double click that, you'll get to the shader editor. Success. Loading. All right, so if anyone is behind, stop me. I'll just keep going until I hear a stop. All right. So just to explain. Oh boy, that was fast. What's wrong? One next to you, and just, I mean, there's more than enough to figure out. So this is the main screen. You may not have this panel here on the left. If you don't, there's a button here on the top right called Blackboard that will enable and disable it. And you should usually have it enabled because you'll need it a lot. So the three parts you'll see are the main area in the middle. You can use middle mouse to scroll on there. I think like Alt, click, drag also works for those who don't have a middle mouse. That's where you create nodes, and you, here, I'll just like a vector, you can define nodes, you can drag from an output to an import, and then that will be connected, and the output of this will determine what this is. The big block you see here is your master node. Everything that you eventually want on the screen needs to be connected to this. So this has a bunch of different properties like position, base color, normals, bend normals, smoothness, alpha, etc. We'll get to that when we need them. The main ones you usually use is base color, emission, and alpha. That's sort of the base color is just what color is the object with lighting. Emission is what's the color of the object without lighting. It's sort of stacked on top of it. So if you give something white emission, it's just going to be completely white, no shadows, nothing. Alpha is how transparent something is. Those are the main three we're going to use now. So let's, yeah, that's the middle. The bottom right is your preview. It's, I think you can drag it, but you can't see it right now because there's no details yet. That is updated live as far as it can do that. And the top left is your Blackboard, and that's sort of where you define, right, when we had the thing with the properties, that you could define like I need a texture, I need a color, and I need a value. You do that here. You say, if you click the plus button, you can pick from a bunch of data types and say, okay, I need a color. And then you can name your color, I don't know, main color. And from then on, you have a main color. You can drag it from here onto the canvas and connect it to something like, let's say, base color. And then this is the step that usually is not very clear. There's a save asset button here on the left. If you don't click that, nothing happens. So remember to click that after every change that you actually want to see in the scene. So if we have this, you have your shader here, right? That's now in there. You can right click that, create, and then go to material. That will automatically create a material with that shader assigned. And you can see here we've got the main color property. We can set it to red or something. Beautiful. It's transparent now. It's not too good. And this you can just assign to your object, and there you have it, a red sphere. This is the simplest shader you could possibly make, just something with a color and it'll render. Alpha does nothing right now because we haven't connected that. So has everyone followed along to this point? Anything unclear? Okay, cool, let's keep going. Let's continue with the presentation then. No, I don't need to save this, it's not very good. So, calling back to the previous presentation, who still knows what a UV map is? You discussed it last time, right? Okay. So, just as a reminder then, a UV map is basically, it's a list of points on a texture where you say, if you have a sphere model like this Earth here, it's basically a property that says this point is there on the texture and this point is there on the texture. So it sort of determines how an image would wrap around a 3D model. Like if you have a flat plane like the ones in the earlier scene, it's super easy, but for a sphere it gets complicated. For a model of a human, it gets even more complicated. So in the simplest version, you just, this is baked into the model, right? This always comes with a 3D model. And then you assign a texture to your shader, to your material, and it shows up on the model. So I can show you. Here you go. I'm just quickly going to add a texture here. Texture, well, whoop, doesn't matter. Instead of the color, we're going to connect that to the base color. Oops. Of course, wait. Sample. I still have to sample. This is the annoying bit about shader graph. It's quite buggy. There. We've got our texture. We're sampling from our texture based on the standard UVs, and we're taking that to the base color, save it. It's done. Now you'll see that this material has a texture slot here. We'll select something like this beautiful beach ball, and now the beach ball texture shows up on the model. These are the, yeah?
Oh, just.
Oh, okay, yeah. Like, what did I break? Yeah. Yeah, this is the default, right? So you can't really do anything fancy with this. Like, you can rotate the ball and that'll sort of move it, but you can't really change this. The trick is with shaders you can, because let's move it over here. So to show you visually how this works, you've got your 3 points on that simple model we had, right? The triangle, 0, 1, and 2. And you've got your UV map, which is X, Y, but they call it UV for some reason. Each of those points is going to be given an X or a U and a V value, which is going to plot them here somewhere on a square texture. So you can see it here that this is, right, this bottom point, 0.2 V puts it there, and 0.45 U puts it there. You do it for all the other ones, and now if you overlay a texture, that's how the texture is going to show up on your model. This is what we just saw in real time. Now the first trick I want to show you is that you don't actually have to use these UVs as is. You can change them at will. Or you can, the simplest one I can show you is scrolling. Like there's suggestions, sort of a baseline for this is how the texture looks good, but after that you can change it. So if we have this exact same situation, but instead we're going to add 0.25 to the V value, it's actually going to sample higher up in the texture, right? So this point is going to have a color applied to it that would normally be there. So let's show you that in the actual editor. In fact, I already have it here. This is the end result. You can see you can just sort of move the texture around on the object as you're changing the offset. So how does that work? Let's go to the end value. Oh, sorry, this one. So, same trick so far that we had earlier. You've got your master node, there's something connected to the, here it's called albedo, it's the color. You're sampling a texture, and you're putting a main texture here in your blackboard, and you're putting that into the texture sampler to tell it what texture to actually sample. If you're using default UVs, if you don't have this line connected, it'll just use the defaults. It'll always put the texture in the same place as defined by the 3D artist. In this case, you can also get access to the UVs here. So if you press space, you get a list, and then you type UV. That's how you get that node. If you connect that as is, you still get the exact same thing. This is just how you're using it as it was supplied. What we're doing here is we're taking another thing in the blackboard. So you've got, I called it V offset, but you can call it anything, like a slide or something. And that's just a float, like a normal number between 0 and 1. You can drag it into the scene. Here, I'm just going to get rid of this for a second. We've got our UVs. And then you've got your offset. You can add them together. So you drag this out, type add. You'll get an add node. Connect that to the other port. Connect that to the UVs that it's going to use. And now you have what we showed earlier. Except it's not quite the same, and I'll show you how. It's also going to slide sideways, right? Because UVs is a vector. It's two. It's a U and a V. And now we're adding this value to both of them. So it's going to slide sideways, or diagonally, actually. If you want to filter that out, there are a couple of tools you can use for that. So before adding it, we need to make it that it's a vector of two components, but only the V component is actually used, so the vertical. There is the, you can use component mask, I think that's our mask, channel mask. Yeah, that should work. No, wait, that doesn't work. Easiest way is probably to combine. So combine is a node that allows you to take a bunch of different inputs of one component and combines them together into like a vector 3 or a vector 4 or whatever. In this case, we need a vector 2. So we take this RG, that's the vector 2, and we connect the V to the second port. So that's going to be like the first one is U, the second one is V. And then disconnect this. Now the output of this, for some reason it is not visualizing it here, but it should actually only be, yeah, it should be green in this case, because we're only using the green channel. Now, it should work properly. Yes, there, because just scrolls down. So this is manual, right? If you wanted to do this continuously in your game, you would have to have a script that constantly updates this value. It's quite annoying. You also have access to time. You have a time node, and instead of that V offset, you could connect the time output there. This will probably be quite fast, but it should work. After I hit play. There you go. Now it's automatic. So this is obviously a fairly boring example. It's a texture that scrolls a bit down, but you can do more exciting things with it. So take a look at this. These are just simple flat meshes, actually, or not really flat, but yeah, I can find them here. Oh, it's tiny. I hope you can see it. See, it's just a static little bent plane. This is doing the exact same trick. It's taking the water texture, sliding it over it, and because of the way the model is made and sort of bulges in and outwards, you get these distortions here. Because of the way the UV map is a bit stretched at the vertical part, it falls faster there, even though it's still just scrolling. The white part, the foam, is still just a texture that's scrolling over top of it. So hopefully if we're fast enough, we're going to be recreating this from scratch after the dinner. So I'm just going to rush through it. Is anything unclear so far about the technique used? No? Don't be afraid to ask, because this is a lot at the same time. Yes, let's continue. We already did that. So this technique. It's called UV scrolling. It's useful for creating motion in static material. So instead of moving the object itself, you can move the appearance of the object. So, right, you don't want to move the whole sea to make waves. You just move the surface of the sea. In that case, it's a lot easier. You can do this multiple times per material, right? You can have one texture that slides this way and then another one that slides that way, and sort of blend them in interesting ways to make what looks like random noise, but actually it's just two pictures sliding over top of each other. And you can do looping effects with it quite easily. Like the time we use now, you can also use a sine function instead of time, so it just goes up and down the whole time. Yeah, waterfalls. So the takeaway from this is you can sample the textures however you want. The UVs are only a suggestion. You don't need to just use that static UV set. Next one, a bit of a fancier version of the same technique. Right, now we're taking one, oh, what is it doing? Yes, there we go. So it's the same as UV scrolling. We're still going to move the point that you're sampling the texture. But instead of everything moving at the same distance up or down or left or right, we're going to make it different for each part of the model. And we're going to use a second texture to control where this is going to happen and in which directions it's going to happen. So if you want to see some end results where you would want to do this, if you want to have fake refraction, like this effect, for instance, on the windshield of a car, you can do this with UV refraction or UV distortion, right? You take the texture behind it, and then for the water drops, you decide, okay, actually you're going to sample from there, and you're going to sample from there, and then you get a water drop. It's used a lot in fire effects. You create a certain shape for the flame, and then you have all kinds of noise and textures blended together to change how it samples. So this is probably just a static plane with nothing moving, but then it's doing all kinds of fancy stuff. Yeah, let's have a look at it. Let's go to, if you want to follow along, it's in the UV folder and then distortion, or C distortion. We have UV distortion here. Yeah, so you see the end result here already. I've added some planes because a gray background is marginally more boring than a white background, in this case with some textures on it. So here's an example. This is not the best example, but this is just a static plane. There's nothing moving about it. There's just one texture on it, and then another texture being used to sort of change the way the texture is being sampled. Another example, the one that I showed you earlier in the presentation, same thing. Static plane, the actual mesh is just, oh, okay, well, we're not allowed to see the mesh, but it's just a plane. And it looks like frosted glass, even though there's nothing fancy about it. There's a bunch of different settings you can change on it. Here, distortion strength, you can set it way up, and then you have trippy glass. But and if I set distortion to 0, you almost can't see it. It's just taking the texture behind it. There, let's set it back to default. Let's go for the fire thing at the back first. Transparency, simple distortion, end. There. Okay, so a bit of a bigger graph. Still sort of the same thing. Everything up to here is the same, right? You've got a master node, you've got something connected to the color, it's sampling a texture, you're setting which texture to sample, and you're supplying a set of UVs. So that can either be the default or the one we scrolled earlier. In this case, we're going to do something a bit bigger. We're going to add something to the default UVs. And that's this whole section. I'll drag that out for you so you can see it better. There's a lot of repetition in here, so it's not quite as complex as it seems. There. So, what we're doing here, we're sampling two textures, two noise maps. Noise maps are basically they're convenient things that artists often use to, you know, affect the way these materials look. So they're typically tiling. They're not really of anything in particular. They're just convenient shapes that you can use. There's a lot of free ones out on the internet, and there's a bunch in your project already that I've included, so you can use them later on. In this case, we're taking one scrolling texture, so UV scrolling, the whole example is here. We're scrolling this sort of wavy thing down. Then below that, we're scrolling this sort of cloudy thing up. So that's going to result in this and that. When you multiply those together, you get this sort of effect, right? Which almost looks like this vague sort of random noise, even though it's just two pictures. If you have better textures, or you can really tweak with this to make it look really good. So if you have this output, I'm not sure what, oh yeah, we're multiplying with distortion, doesn't matter for now. If we just took this and added this to the UVs, it would do some funky stuff probably, right? So you see the output of the waves on top of the regular UVs now. Problem is the waves are white, so it's going to distort in all three directions. It's going to distort sideways, U, it's going to distort vertically, V, and then also blue channel, which is probably ignores, but you don't typically want that in there. So yeah, there you go. This is a bit extreme. It looks okay, but it's not what we want. It's also because the distortion is a lot, right? White in this case is 1. You're going to use a lot of black is 0, 1 is white, and everything in between. If you're going to have a white point on here, that means it's going to just loop around the whole texture and go all the way to the other side, right? Because it's an offset of 1. So you're going from sampling it here to like maybe going around and sampling it there or something. That's way too extreme. So that's what we're doing here. We're taking that distortion, which is another thing added here as a property. It's just a number between, say, 0 or 0.25 or something like that. We multiply this with that to make it darker. So the effect, like the thing we're going to add to the UVs is a bit dimmer. Then you take a channel mask node, which is sort of the reverse of what we did earlier. In this case, we're taking out everything except the green, which is the V, the vertical offset. So you have a setting here that says, okay, do you want the red, the green, the blue, and the alpha, nothing, or everything? Everything that you deselect is just going to be 0, so black in this case. I'm multiplying it with something else. I'm not sure why. I'm not even sure what I'm multiplying it with. So it's probably not that important. I'll restore it later. Oh yeah, it already works. I don't think this actually does everything. It just, oh, it flips it to minus. Yeah, okay. So there you have it. If you look at the properties on the material now, you have those three, right? You have the main texture, the one you're actually going to be displaying on the model, and then you have the other two that are the noise maps that you're going to be scrolling over top of each other, multiplying to make random noise. And then you have your distortion setting, which is controllable to decide, okay, how extreme should this effect actually be? If you set it to 0, nothing happens. Somewhere in here is probably nice. So that's, you know, I'm sure you can think of other materials that would probably work better this way. The water one in the waterfall is a good example, right? So instead of just moving the water texture to the side, you can also just sort of swish it around a little bit, make it look more like water. Yeah, the other version with the transparency here, it's basically just the same thing. Where is it? There, I'm going to open that, select. No, is it? Oh, UV distortion. Here, end. It's, yeah, I only used one noise map here because it's glass, right? It's not moving. You don't need to scroll them on top of each other. It's just static. And instead of sampling a texture, I'm doing a little trick here. I'm sampling the scene color. So that's everything behind the object that you're actually rendering. So if you imagine you're making a shader for this laptop, then the scene color at this point is going to be that. It's usually, it's a fairly expensive thing to use, but most modern hardware can get away with doing it like 10 times per frame easily, so per pixel, per object. So it's something to watch out for, but if you need transparency, you need transparency, so use it. Yeah, are there any questions about this type of effect? How it's made, what you're gonna, or anything to watch out for, or you could try making a version actually, if you want. Yeah, let's do it. I'm just gonna destroy this one, or not destroy, just close it. It's a bit extreme. If you make a new shader, so right, go to your assets, create shader, and then HDRP unlit probably. Right, let's go for the transparent effect. It's pretty cool. And call this new transparency shader. And open it. Or actually rather also create a material for it, just so we have it. And then assign that to the plane here in front, the transparent plane. Right, so just created a new default unlit shader, made a material for it, added it to the quad, the plane in front, and then it just looks boring and plain. Word jokes, the best. Yeah. Sorry. I'm not sure why all this is showing up. I need this. Is everyone at the same point now? You have a shader, you have a material, it's set up on the plane.
Why is rose?
Hmm?
Why is
Oh yeah, that's
color?
because the thing is still broken. I can fix your thing, but we should do it during dinner because it might take a while. And then
Okay, no problem.
okay, so let's say what should we make? Let's make a moving glass just to get into something impossible. Just something where the glass is distorting and it's moving. That sounds fun. It's nice and realistic. So the first thing we're going to need, right, the scene color. So press space, scene color. Connect it to, let's say, emission probably. Because we don't want that affected by lighting or shadows or anything. We just want the exact scene color behind it. If you press save asset now, we're probably going to run into some trouble. Yeah, it's going to be black. It's because it's not a transparent material yet. So it's not actually rendering anything behind it. In order to change that, you can right-click this, or not right-click, click the little gear icon here on the master node. There's going to be a bunch of settings. The one we're looking for is surface type, opaque. You can set that to transparent, which means it is rendered after everything else is already rendered. It's always going to be in front, so there is going to be data behind it. None of the other stuff really matters. Save the asset. And it's still broken. Excellent. Because we're not sampling it in anywhere. Okay, yeah. So normally you would use a UV, right? This still needs to know where to sample the screen. Actually, wait. Sorry, this is another glitch with. Here, if you go to your material, the one you just created. The surface options are also in there, so you can set it to transparent there, and then it'll actually disappear, which is exactly what we want, right? It's still there, but it's the color of the exact pixel behind it. So that's good. Is everyone at that point? You see nothing now? Yeah.
No, nothing yet.
Oh, let's see. So, close this. It's called. Sorry. Create a material for that. Yeah, default name. And then create, I don't know, a sphere or something. Work. And add it to there. Yes. Okay, so this is your default shader. I'm just gonna give it a little bit of color because we can't see anything now. There, set it to gray or something. Now it should be, yeah, there we go. Now it's vaguely transparent.
I'm not getting that.
Hmm?
I'm not getting there, and I'm not sure why.
I'll just quickly come over. Right click op de shader, create.
Oh, next up.
Ja, dus die mensen die nu en hij is de boring plane wat in de shader als dat is. Precies. Dan kan je die stappen doen met die scene color center. Nou, dit is gewoon je normale kleur die je kan instellen nu. Als je hier spatie, gewoon ergens, ja, en dan het scene color. Ja, ik zag wel die maar there you go, scene color. Daar, naar je emission toe.
Maar dit is ongeveer tot
ja, emission is gewoon, ik wil letterlijk deze kleur. En die andere color is, ik wil lighting. Dit is een dag, nu zou je een onzichtbaar model als je het onzichtbaar zou doen. Bijna hier zelf.
Niet een material nog een keer maken.
Nee, dat klopt wel.
technisch gezien is dat deze is best krap.
At least I had a nice car.
Ja, ik weet het
Als je
zeker.
die naar
No, I install all packages, but it doesn't
in color
project
overheen
and
blenden.
download the picture.
Yes.
Save asset.
Packages are uninstalled.
Hij is nu zwart, oké. Emission.
Create.
Ja, die nog niet.
Oh ja, alpha staat nog op min 1.17. Als je dit op 1 zet, ik kan me voorstellen dat dat rare dingen doet. En dan de alpha clip threshold gewoon op 0 zetten. Dan, precies, dat weer 7. Ik ga anders even, zo even meekijken. Kom dan even een stuk verder. Yes. So 5 minutes of top break. Let's hurry this up. So, most of you, I think, are at this point now. You have a plane that should be roughly invisible or even entirely invisible. I see some yeses and nos. Okay, cool. I wish this software would be a bit less buggy, but there's a lot of you change it here, and then if you do it in a different order, you have to change it somewhere else as well. So I'll try to troubleshoot you near the break. Yeah, so right? We have we're sampling the scene color, and it's putting it on the plane without any lighting, so we're seeing nothing. What we want to do is actually sample the scene color, but at a slightly different point, so that we see the distortion effect. So in order to decide where we're going to sample, we need a texture, right? We're using a texture for that. So go to your blackboard, add a texture 2D. There are other options, but they're basically useless for most regular shaders. We'll call it, I don't know, distortion texture. Doesn't really matter that much. I'll set the default to black, but just thing. And you can drag it into your scene, and now you have that texture there. If you drag out from there, we can sample it with the sample texture 2D node. For this, we can just use the default UVs. We only need to affect those if we're actually going to scroll or change this sampler as well. So this is going to give us, let's actually pick a basic texture for it. If you open it in the blackboard, you can pick a default texture, and that's going to make debugging a lot easier. Just pick something, anything that looks vaguely black and white. Should be good enough.
I'm getting some online feedback.
Oh boy.
Someone wants you to create a hologram.
A hologram, yeah. Okay. I can do that. After break, though. Yes, so I've just set as a boring white-black dot as a texture. We're going to take the output of that. So we only need one color, right? It's 0 or 1. So we could just take the red component. And we're going to do the combine trick again. So we only want one direction of offsets. So let's put it to the green one, which is vertical, and the red one's horizontal. Now we have this, and we're going to add that to something, right? Because it's using default UVs now. What you can do is go to the node screen position, which is sort of the same thing as UVs, but instead of being for one model, it's for your screen. It asks Unity, hey, this pixel that I'm rendering right now, where is that on the whole screen? So that's the input for the scene color position. If we just connect it directly, there should be no difference. It's the same thing, right? It's the default. But if we add the thing we just calculated to it, so we're taking this one, the 2-component vector, adding it to the default screen position, and then using that to sample the scene color. We're going to get some very distorted things, probably. Oh, nothing is distorted. Excellent. I love it. It should be. Wait. See, there's another glitch. The texture isn't set in the actual material. When you do set it, you get this black hole, which is a bit extreme for glass, but it does work. It's actually a fairly good black hole effect. Interesting. So if anything that you've done so far doesn't work, check the material itself, because sometimes you set things in the defaults and then it doesn't carry over to the material, or you set a certain property in the shader and it's not the same setting in the material. You should all roughly have something like this now. Is there anyone for whom that isn't the case? Yeah, because it's broken, yeah. Okay. Yeah. Alright, so I think you all want some dinner soon, right? The one thing that's still, why this is so extreme, is it's still sampling that texture, and it's going from 0 to 1, so a whole screen offset. It's probably best to add to the go back to the blackboard, add a vector, which is just a float, a vector 1, call it offset strength or something, drag it in, there, and we're going to take that that green dot that we calculated and multiply it
Nee, het is nice.
ook. Ja, toch.
Ja, dat is echt perfect getimed.
Alright, so. Ik wil de deur even. Was er iemand weg? Or-
Geen idee. No
Ja,
idea.
eentje is weg.
Okay, alright. It's a bit cold. So, after dinner and some tech issues, let's continue. I'd say if anyone is having consistent problems with their laptop, team up with someone because I don't know how to fix it within the time constraints we have now. It's a bit annoying, but there are a couple of network issues blocking the package manager. So, wait, so the last thing we did was this. Nee, okay. So the last thing we did was this distorted effect, right? So I made it rotate, but we made it pan earlier. It's the same kind of logic. So let's quickly recap what that was all about. Yeah, so these effects, this is basically what we created, just a simpler and less detailed version. How you would make these flames, for example, should also, right? You can probably imagine how you would do it based on the technique you learned earlier. So you would have the colors of the flame somewhere at the bottom, and then have a texture scroll across the top of the plane that the flame is on and sample down at different points. So that's one way you could make fire cheaply. So the takeaway from that technique specifically is you don't have to show the textures. That's not the only purpose of a texture. You can also use them as input, as data. So for example, where to move, how much to move, which parts are invisible, which parts are visible, etc. So we already dabbled a little bit in it with visibility and transparency. I think it's a good thing to just quickly go through the different settings that we encounter and all the different blending modes that there are, because there's more than one way to make something transparent. Yeah. So the first thing, obviously, is the rendering engine is quite intelligent about what it needs to render and what doesn't. And if something is behind something else, it just won't render it. So you can't sample through it with the scene color if you don't set something to transparent. If you set a material or shader to transparent, that basically tells the engine, hey, render this after all the solid objects have already been rendered, regardless of where it is, because then you can actually, right, you can make a have something that is a bit translucent, like you have a thin sheet of paper or something, that's alpha blending. It's just this color in front of another color. When you have a fireball, that's not that's adding something, right? There's light coming from the fireball itself. It's on top of what's already behind it. So you would use additive blending for stuff that lightens a scene, and then multiply is for when you want to darken things like dust or smoke or whatever. When it doesn't make sense that the thing in front would lighten what's behind it. There are a bunch of other ones like overlay, etc. There's very good resources on the internet that explain exactly how they work. These are the main three ones you're going to be using most of the time. So just to quickly show you what that looks like in the shader editor. There is a scene here, 2 blending modes, and then blending modes. It's a very good name. 2 basic shaders here. They're not very exciting. They both look the exact same, actually. One has an alpha mask, and the other one is additive blended. In this case, because it's sort of a light, it's a dark texture with light streaks on it, the effect is the same. Here I can show you. So as before, you have the material options. So it's set to transparent, and then you can set the blending mode here. So you have those 3 options: additive, alpha, and pre-multiply, which isn't the same as multiply. I'm not sure why that's not showing up, but okay, interesting. I'll have a look into that. I think newer versions do have that. It's because of the HD render pipeline that we don't have that option. So this shader, let's open it. Masking. This is basically the same thing you would do in Photoshop, right? You have your texture, which is everywhere. You just set that to the color. And then you have another texture, which is your alpha map. So again, it's using a texture as data rather than something to show. And this determines which points of the image are going to be completely visible where it's white, and which are going to be completely invisible where it's black. You set that to your alpha port here, and then the master node will do the rest of the work for you. Again, here it's important that you have transparent and alpha blending set. The other one, the additive blending, is this one, where we're doing this ourselves. So we're taking the color, we're taking our alpha map, we're multiplying them together to make this texture. And then if you set this to to additive blending, that will have the exact same effect as what you did before, right? Only the light parts will show up, the dark parts are transparent because you can't add black to something. So just 2 quick examples. It's the same end result, but it's 2 different blending modes. They have different effects. Where this gets interesting is what we can do with transparency. So technique number 3 that I want to show you is alpha erosion, which is the idea of using a texture to not only determine which parts of a model or an object are transparent or not, but to somehow animate how do you say that? What sort of the cutoff is, right? If there's a certain gray level and everything below that is invisible, for example, then you can move that level and then the object will fade out in a certain way instead of just uniformly fading out as if you lowered the opacity. So what can you use it for? Like I said, anything that needs to fade out, but not in a linear, just fade, but more of a dynamic thing, like these splashes here. These are alpha eroded, or they're flipbooks. It's really hard to tell. But I think there's some degree of erosion going on there, right? So the big splash here afterwards starts as a big splash and then slowly fades into little droplets. I'm pretty sure these are not actually droplets, but just one texture that is being eroded. Another one, there's a ton of it going on in this recreation from, I think it's from Breath of the Wild, one of the Guardians. You can see the smoke here. It doesn't just fade out, it sort of dissolves in a certain way, right? There's sort of a rotation thing going on. Nintendo is really good at these sorts of effects, so if you want to see good examples, play Breath of the Wild. There's a ton of it in there. There's actually more going on with that, but fireballs, like same thing. The tail is sort of evaporating. It looks a bit liquid almost. This is one example we did for an arrow effect. It doesn't look like an arrow when you drag it around this slowly, but if you do this really fast, it looks a bit like a wind effect behind the arrow. Again, this is just two textures, the same method we used before. Two textures scrolling over top of each other on a trail renderer, and then you set everywhere that the two textures multiplied is below a certain value, it's invisible, and then you get this. And here's a fun one that you see a ton in games, also Breath of the Wild in this case. This looks really fancy because they did it really well, but it's the exact same principle. Right? He's fading out and dissolving into particles, but really what this is a model with a certain map on it that says, okay, this is white, this is black, this is gray, etc. And then animating up what the cutoff point for transparency is. And then you'll see certain parts fading before other ones. They added a little line where the division between those 2 points is. So the sort of the glow that you see on the edges. Oh, it doesn't let me do that. That's a shame. Well, you can sort of see it here, right? This is a bit of a greenish glow on the edges. Yeah, and then combine that with some particles that appear in roughly the right places. You can also base that on the same map, and then you have that effect. So there is a folder erosion in the blending folder, and that there is a scene alpha erosion in there where I've created a very simple example of an alpha erosion shader. It looks like this when I animate it. Right, so it's not just fading out, there's a certain sort of movement to it, and that's all just set with one texture. So in this one, I can show you the image. Where is that? Assets. No, it's not that one. Okay, I can't find it there. Here, this texture. Show that in Explorer. There. This is the texture that is doing this. Right, so the darker parts fade out before the light part. The light part stays around all the way until the end. So again, we're using sort of a lame fire texture here, but if you used, say, smoke for this, it would look a bit better. It's more appropriate for that type of effect. And then this one, the one on the right, it's the same thing. We're just moving up which level of gray becomes invisible, and then you get that effect. And it's actually linear. There's nothing special going on there. It's just because of the texture, it looks like it's sort of pixely dissolving. So let's have a look at how those are actually made. Erosion. End. Okay, it's reassuringly small. That's good. Again, nothing special here. Take a texture, sample the texture, take it over to the color. Nothing fancy going on there. The other end is we're actually using the alpha port now. So we have this texture, which is the alpha map, which is always black and white. There's this color in there, doesn't make sense. We sample it for every part of the model, and we have the cutoff here. So I'm just going to replace that quickly with this slider so I can show you how it works. This is a value between 0 and 1. If it's 0, it's subtracting nothing, so the whole alpha map stays the same. If it's 1, it's subtracting white from everything, so the whole alpha map is black, and every point in between. And then you can already see sort of how this affects the fade out, right? If I use a different texture for this, it looks different. Again, I can show you. Let's pick a different one. Maybe this one's
The round.
the round one. This one.
Mm-hmm.
That's interesting. It doesn't have that many gradations in it, but it should work, right? So there's a little bit of there's a bit of fading going on there. Right, this works the best when you have a texture that has a clear gradient from black to white. Like if it jumps from one value to another, you get a smooth fade, and then suddenly, boom, half of the model is invisible. So you really want as much range there as possible. So for something like this is, again, you have these spots left over, which were the brightest spots in the texture. So you subtract this value from the alpha map. You saturate it, which is sort of a safety operation that's just saying, okay, whatever comes in, I want the output to be between 0 and 1, right? Because an alpha of above 1 doesn't make sense. Then it's more opaque than a full solid object. And below 0, transparency also doesn't make sense. So this is sort of a safety thing to prevent glitches. You take that to the alpha, and that's it. You've got a dissolve. You've got a erosion shader. The other one for, I think the one with the pixels is the exact same one. Let me check. Yeah, it's the same thing. It's just different textures. You could make this fade out with the same pixels. Pixel, I can't type. There, beautiful. I can't animate it now, but you get the point. I don't know why I'm not allowed to do that. Not allowed to move it, but should work. Yeah, there we go. See, same effect. So, where does that leave us? It's quite a useful effect, right? It makes this is particularly useful when you're going to be using particles, right? So, is everyone familiar with particle systems? Okay. So, say you have smoke, and you don't want to, because smoke doesn't get more transparent, it sort of dissolves, so that's a really great place to use it. If you want to do something like this one, taking a certain model, making it disappear. Here he's using a quite noisy texture to take different spots of the model and fade those out first, but you can also do it based on height, for example. So you, right, I heard the teleport or hologram shader earlier. If you make the same shader, but instead of using a texture, you use how far a certain point is from the ground plane, and then animate that up, and then the model will appear with sort of like a laser line at the top. You can do that with the same technique. So it's quite versatile. It's a fairly unrealistic effect, so it's not something that you want to do too much if you're aiming for photorealism, because you're going to see through your model, and you're going to see it's flat and hollow, so don't usually want that. Which brings me to, let me check, yes, the last fancy technique, and this one involves math. So, Fresnels. These have a lot of different names, depending on where you look and what industry you come from. You also hear rim lights, rim components, edge fall-offs, N.L, facing components, etc. It's all the same thing. It was invented by this guy, Fresnel. He's French. That's how his name is pronounced. It's very annoying, but that's how it is. And basically what he, one of the many things that he studied was the way that things reflect on surfaces. So if you want to see what a Fresnel component does, this is a very good example, looking across the water, right? If you look into the water, you see through it. You see what's below the water. If you look across the water, you can't see into it. You just see the reflection, right? So the degree to which an object is reflective depends on the angle you look at it. That's one of the sort of the natural phenomena you can see where it's in action. So what's happening there? Again, we're going with a certain value between 0 and 1. And basically what a Fresnel component tells you is how no, not perpendicular, how parallel is a certain surface to the direction that you're looking. Or perpendicular in this case, actually. If you're looking directly at a sphere here, the surface is directly perpendicular to you, so it's 1, white. If you're looking all the way at the edge of the sphere, it's pointing away from you, so it's not at all perpendicular. You're looking straight across it, 0, black. The opposite, this is just 1 minus that. Either one, you can use it. They're quite common, both variations. So to illustrate that just one more time, in a shader you can access the view direction. I'm going to call that L, which is the direction from the point that you're rendering on the surface to where the camera is. You also have a normal direction, which I think Jesper covered last week, maybe, who knows? Which is basically, if I have this surface, this is the normal. If I have this surface, this is the normal. It's just the perpendicular direction from the surface. Each point on a model will have that. And a Fresnel is when you take a dot product between those two vectors. And then what it tells you is how parallel they are. So in this case, here, these are almost entirely parallel, so the Fresnel will be 1. Here, they're perpendicular, so not at all parallel. It's going to be 0, and in between, it's going to be like 0.7 something. Yeah. The part at the back is a bit more difficult, because that's technically going to result in minus values. The good news is it's at the back, so you're never going to render it. So you can safely ignore it for now until you use this in a way that you can actually see the part where it's going to be below 0. Otherwise, you can use a saturate node that I showed you earlier, and it's going to clamp it between 0 and 1. So yeah, if we map that on there, you get this. And that's exactly what you see here, right? It's the same thing. So what are those used for? Every lighting model ever, pretty much, except maybe stuff from the Quake 2 days, uses these in some capacity, right? They're used in blend shading, Phong shading, for instance, they multiply the light direction with the normal, and then they take a bounce factor from that, and they take a Fresnel with that and your view direction, and then you get like a certain light value. It all gets very fancy. Good news is this is all default in Engine, so you don't need to rewrite these. It's used for ghost and X-ray effects, so I'm assuming this is what someone was referring to as a hologram shader. Right? This is from Oblivion. It's very old, or Skyrim, I can't tell. It's just the normal sort of transparent, semi-transparent model, alpha blended probably, and then they added a Fresnel component to it to highlight the parts of the model that are facing away from you and do nothing with the parts that are directly facing you. You can use it to fake all kinds of glows, right? These, for example, are meant to show that there's a bright light there. There isn't actually a bright light. It's just a big sphere there with a Fresnel component on it that is light blue. Same thing with these. You can use them in a limited way, but you can use this, make this type of effect with it, where you can just make a bunch of shafts, put a Fresnel component on it, and then the middle of the shaft will be bright, the sides of the shaft will be transparent. Water, that's where it came from. You can make water with it. You can see the effect in action here, like it's reflecting here, and here it's a more normal color. I think this is League of Legends. I'm not sure, I found it somewhere, but they're using a ton of them here to blend all of these different layers together. Right, you have this effect, which is, I think, 4 or 5 different effects that you can see. They're all sort of brighter in the middle. This one is brighter around the edges. This one, again, brighter in the middle. That's all spheres with a Fresnel component multiplied with whatever texture they scroll on them. Layer them together if you're really good at it, and then you get this type of thing. Yeah, so I can just show you how to make a Fresnel component. It's in folder 3, Fresnel, the basics. There, aren't they beautiful? Some highly detailed models I made especially for this. Top one is an inverse Fresnel. So that's the one where you see what is facing away from you, and the bottom ones are normal Fresnels, which are you see what is directly facing you. You can see for the sphere, it doesn't really matter what direction you look at it, it's always the same, right? Because it's a sphere, it's the same from all directions. Same thing here. The capsule gets a bit more interesting. That one has, right, if you face the side directly to you, you get a bit of an elongated thing, and the ends are just spheres again. Planes, you can see this interesting effect. You get a dot, or sort of a bump where it's lighter or darker. This is actually because you're not looking at the plane at the same angle for all the points. Like the middle, you look directly at it. This one, you're already sort of looking at it from an angle, so it's going to be lighter because it's facing away, or it's more perpendicular depending on where you are. You can stop that, but that goes beyond the scope of what we're discussing here. So how do we make one of these? Let's open the shader. There. It's here. It's basic Fresnel end. I'm gonna make the preview a bit smaller because it's huge. Right. Again, nothing really special. I'm going to show you the quick way, and I'm going to show you the way that actually explains what I'm doing. The quick way, press space, type Fresnel, and you have a Fresnel component. But that would be way too easy.
Is this a custom component that you...
No.
It's just in there.
This is all. I made the better Fresnel. That one is a custom component, okay, which is all of this stuff below here. It's just this kind of hides what's actually going on, so I wanted to explain to you how to do these sort of calculations. It's more useful. Also, there are certain things missing from the shader graph Fresnel that are useful, like a bias, being able to sort of shift it up or down if, a little bit. So, the full way, right? We have the view direction, and you have your normal vector. So that's how am I looking at the object, and where is this part of the object facing? You have a node called dot product, which is the thing, the math operation I described earlier. It says how parallel are these two. So you plug those in there. You take the absolute of that because, again, you can have negatives, right? So if this one's facing there and that one's facing there, you're going to get a negative dot product. So absolute is a good way to sort of get it the same on both sides of the surface. And then you have a power node after that, which is basically saying like, all right, take this value and based on how vertical or horizontal it is. That's all it is. And then there's a bunch of settings I exposed here. So like you can make the edge softer or harder. Soft, it gets really weird right here. 2 there. This isn't really what normal snow looks like, right? You don't get like half snow at the edges, so I made it a bit sharper. There, make it sharp. And this is the bias, so just to shift it a little bit. And that's it. This plane actually also has the shader, but doesn't have a different texture, so you can't see it. So that's one example where you could, right, instead of having your texture artist go through your whole level and adding snow everywhere when you maybe want to change it, this could be a solution. Another one is this one, which combines 2 different effects that we already discussed earlier. Right, so we have a drone with jet engines for some reason, because that's what drones have, right? The jets are 2 components. There is the sort of, oh, they're gone now. You see, like, there's distortion going on, and there's this, the sort of highlight, the fire, I'd say. If you zoom in on the fire, that's just a donut model with a Fresnel component on it. It just says, okay, everything that's directly facing me, make it bright. Everything that's facing away from me, make it sort of darker blue, and it's transparent. And you have this. Make it blink a little bit, and suddenly it starts looking a little bit like fire. The other thing, this distortion around the edges, you can make a really expensive effect out of it, but really what this one is, oh, it's really annoying that it won't show it. If I just make a default material, you can see it. There. Beautiful engine cone. That's all it is. It's a cone. It has the same shader that we made earlier, right? With take the color of the scene behind it and distort it a little bit based on a texture. Move the texture down so it ripples, and then you use a Fresnel so that it only shows up around the edges instead of in the middle as well. And that's it. So this, obviously, once you get to this level of graph, it gets a bit more, right? It gets bigger. It gets a little bit harder to discuss the whole thing, but you can sort of see it going on here, right? Tiling textures, taking certain parts of it, multiplying them together to make it fade out near the bottom. Right, this is the top of the engine, this is the bottom of the engine. Taking the Fresnel to multiply it so that only the edges show up. And then you're there, take the scene color, and you have air distortion. Yeah. Just trying to go faster. So let's recap quickly what we discussed so far. We've done 4 techniques, right? We've done UV scrolling, so taking the UV map as is, moving it around. We've done UV scrolling, distortion, which is the same thing but moving different parts around by different amounts based on height, distance from something, a texture, a color that you set, whatever. You can animate those. You have access to time in your shader. You have access to values that you set from the outside, so you can animate a whole bunch of stuff. Transparency. You have different blending modes. So normal transparency, darkening, and lightening. This lower part only applies when you're using Amplify Shader Editor. This is basically tells it, okay, render this after everything else is rendered because it's transparent. Using textures as data instead of just to apply color to something. So alpha erosion, controlling how to fade something out. You can use it for UV distortion to determine where certain parts of the texture should distort. You can use it to mask certain effects, like the distortion in the jet engines I showed you earlier. Like, okay, I want to distort the texture behind me, but only at the edges. You can do that with textures. You can also do it with Fresnels. You can multiply and scroll 2 different textures on top of each other to create randomness and create something that a player will not be able to recognize as a scrolling texture. Right? If you've ever seen a bad water shader, you can literally see the texture moving over the top of the surface. If you take 2 or 3 samples and just multiply them together, you really have to know the texture well to be able to see this. And it's pretty cheap. You can, I think the first limit is actually like 11 texture samples per pixel or something. That's where it starts complaining. So you can do quite a lot. And if you want to get fancy, for most of these effects, we only used one color out of a texture, right? Just one value from black to white. So you could pack 3 textures into a single texture, put one texture on the red channel, one on the green channel, one on the blue channel. It's gonna look like nonsense to a human because it's gonna have all these random colors, but for a shader, it's no problem, and then you only need one texture. It saves memory. Yeah. Yeah, oh, the quick recap for the Fresnel. You can create soft fall-offs with it, you can highlight contours, you can control effect strength based on where something is facing, if it's up or towards you or to the sides, horizontal, etc. And it's used for lighting calculations. And if you really want to know about the lighting calculations, there's a link at the end of the presentation. Yeah, so again, these links are pretty good. There's, right, we've done the visual programming version of it with nodes and a certain system that Unity's built for us. The actual shaders behind the scenes are still text. If you want to know how the text version works, and I do recommend it if you dive in deep enough, because it's going to be a lot faster when you control how everything works. This is a really good, the bottom one is a really good introduction to how Unity specifically handles this on the text side. Here's another tutorial. The middle one is a tutorial for the shader graph. We've gone through most of this, but they probably explain it a lot clearer and slower than I just did. And then here is a guy who takes games and picks a certain effect like, oh, that's cool, the wings in Diablo 3 look really good, and then just recreates it and tells you exactly how to do that for your own game. So that's also a really interesting one. This is the part that I showed you at the beginning, like the whole render pipeline. How does it work? What actually happens on your GPU? And for other good examples of like really professional VFX work, there's realtimevfx.com. You can also post your examples there for feedback and ask people to critique it. It's fairly helpful. Yeah, I want to move to a general workflow. So, right, where do you start if you actually want to add something like this to your game? Right, we already have one big leg up on where it used to be a couple years ago, because then you had to start in text and it just took you 2 days to get to a working shader, and then you'd see the effect and you're like, no, I don't think we should do this. That was, still is annoying. These visual editors allow you to skip the whole like, oh, how do I do this, and just drag stuff together and do it, see if you like it, and then decide how you're going to do it technically or integrate it. So always start with references, right? So if you want to create a water shader, look for games that have water that looks like you want it to look. Look for actual photos of water. Look for other reflective objects, like what can you see that you want to recreate that's essential to what you're trying to create. Optionally, and I do recommend this a lot of the time, but it depends on how artistically inclined you are, create a mock-up, right? So if you have the perfect reference, someone has just made literally what you want to make, use that. Otherwise, like try to sketch it or you know, do a Photoshop render of it or something like, okay, this is the target I'm shooting for, and then you can keep comparing to that. Because you're gonna run into tech issues, as we've done a lot of times this evening already. It's easy to lose sight of what you're actually trying to do because of some sort of technical limitation. So that really helps. Make the prototype in the visual editor, so that can be as inefficient as you want. Just drag it together, make it work, get something on the screen and see what you run into. Then, only after you're happy with it, make it tweakable and fix the glitches. There are going to be glitches, and they're all going to be very specific to the effect that you're creating. And right, you can, in the blackboard on the left in the editor, there's a lot of stuff you can expose. If you expose everything, you're going to have a material with 1 million properties on it. Nobody can use it. If you expose nothing, the only thing you can do is drag and drop, and then your level designers or artists or whatever are going to be frustrated. So fix certain things that are always going to be the same, and expose certain things, and be mindful about what you expose and not too much. Only then move to text, and that's only if you need it, right? shaders that Shader Graph and Amplify and stuff make are fairly efficient. They're still not as efficient as they could be if you did it in CG, so text programming. It's usually a good idea if you really have this in production and it's a performance bottleneck or something, then you go through it and see like, hey, I'm sampling 3 separate textures, that could be one texture, or hey, I'm reusing this thing 5 times and I'm getting it every time, I can just store it, for example. But that's your last step, because that's the annoying part where you really have to dig into the technical stuff, and a lot of it is not well documented. But that's where you used to have to start, so yay. So let's try to apply that process. Who of you have played Overwatch? It's a nice little indie game. It's very under the radar. Yeah. So we've got Winston, a big monkey with a shield.
That's outdated.
Yeah, this is a very old. Actually, I've found several different versions of this shield even, but yeah. Yeah, so taking this as a reference, if we want to create this, the only thing we need is a model of a sphere and a monkey. The monkey's optional. You don't really need it for the shader effect. Yeah?
He's a scientist, not
He's
a monkey.
Sorry, okay, yeah. But he's still a monkey, right? No, he's just a scientist. Okay, all right, well,
He's
you know.
clarified this himself.
Okay, that's good. I'm not a lore person. I'm more of a shoot people in the face person.
Talks like that.
Yeah. Okay, well, sorry for all the scientist viewers then. Yeah, so let's take a look at this and do step 1, picking apart the reference. Like, what are we actually seeing here? Like, can anyone name some things that are apparent here? Yeah.
The ring moving down.
Yeah, okay. There's sort of a pulse going down the whole model, yeah?
The light in the middle.
Okay, yeah, this I think this is technically, you mean this thing?
Yeah.
Yeah, that's a separate object, but yes, it is there. Yeah.
The light on the edge seems to be Fresnel.
Yes, correct. There's 2 actually.
Also at the bottom where it hits the ground.
Yeah. Yes. Yeah. This different particle being hitting on the shield here. The shield itself doesn't seem to react to it, so that's good. We don't have to do anything with input from where projectiles are striking it.
I also see a kind of ocean effect on top of the shield.
This here, yeah. Yeah, there's a bunch of textures, right? It seems to be moving a little bit. Here here near the top, there's yeah, it's not as sharp here as it is on
And
It's
there's
all
actually a Fresnel on that.
yes, there's
In the middle it's almost completely transparent, whereas at the edges you can really see
Yeah.
the texture.
you can just see straight through it here, right? There's just a little bit of a blue tint, and here there's all kinds of effects. There's even a bit of distortion going on there at the edges. So, like Blizzard does, they always make these things really detailed, but the basis is actually really simple, right? You've got your Fresnel, one sharp one for an outline. You've got sort of a faded one for the texture overlay. You've got the band moving down. It's transparent. That's a good starting point. It's 2-sided. You can see the inside of the sphere. There are, let's see, the textures seem to be moving, so that implies that there are at least 2 textures being multiplied together or scrolled somehow. What else? There's a fill color. There's even where there's nothing interesting going on, there's sort of like a bluish overlay. And it's being blended somehow. Like, what kind of blending would this be? Additive, alpha, or multiply? Like, is it darkening or lightening? Lightning, yeah. It's probably additive blending then. Because this, it would not make sense for an energy shield to make something darker. So that's where you would use additive blending. So, yeah, and then this one, this is, let's say, a stretch goal for if anyone of you managed to recreate that one. That one requires a depth map. So the distance between the sphere, the point on the sphere, and the closest point behind it. Right, so if he would get close enough, he would actually get the same sort of highlight, unless they patched that out somehow. Yeah, I'd say there are assets. There's all the textures you theoretically need to make this are in the assets folder. in the. Wait, I'll show you here. There is scenes, case, and then a beautiful scene called Winston, which already has the finished effect in it, so don't use that one. I'm gonna delete that, but it's not gonna affect you. And then you have a folder assets in there, which has a bunch of different textures, so the sort of hexagon map that's being used on the spheres, an inverted version of that for the panels in between the hexagons. There's sort of a fade ring here. Two different versions if you want to use a big band scrolling down or a small band scrolling down. And there's a very exciting model of a sphere. So I'd say, yeah, have at it. I'll be walking around and trying to help out where I can. I'll be leaving this slide open just as a sort of reminder of all the different effects going on. Yeah, give it a try. Maybe pair up if you're having difficulty with it, which makes sense because it's quite a lot. But
Maybe it's a good idea to fix at least.
yeah, yeah. To be honest, I don't know how to fix the error there. So what I could do, like if we do need the screen still. Otherwise, we could use my laptop. But
Let's see what's going on.
Imported the project, I imported the packages, but every object inside it is the score.
Oh,
yeah, if that's your art style, that's good. If it's not, then
No, it's not
yeah.
our art style. And if you look to the, for example, the same for
Just gonna have a look.
What I did to get it working was create a new project with HDRP and then take the assets that he provided and shove that into that project.
Interesting. Hmm.
Yeah,
It feels like a scattershot approach. Like we're just trying things and some of them work. It's so weird how this. Yeah.
it works. That's
Yeah.
the thing.
Exactly.
new project.
Let's see. Do we have anything else?
We create a new project and we create a high definition output project, yeah?
Let's see what we have.
Yeah, yeah, that's so bullshit.
Eigenlijk is gewoon die approach. Ja.
Ja.
Wou je nog iets vertellen?
Nee, het is wel zo. Gewoon even proberen.